Okay, so second section we're going to look at this week is 3-4. And it's going to show us two things. First thing we're going to look at is what's called the rational root theorem. And then we're going to look at a quick way to do division. But the quick way only works some of the time. So functions can have both rational and irrational roots. Can someone remind me, what does that term mean, rational? What does rational mean? Like if a number is rational. Brendan, do you remember what that means? Rational? I don't. Well, Eric, you know what rational means?
I mean, I don't know, like, what the definition is, but like, it's not an imaginary number or something like that.
Okay, so rationals are not imaginary. They're real, but we got to be more specific because there's lots of things that there's a difference between the two, between rational and irrational. Chris, do you remember?
Rational is not a whole number. Irrational is maybe decimal or something.
Okay, so we're kind of on the right track with that. You said something about decimals, yeah?
Right.
Fractions, right. Which ones are fractions, rational or irrational? Rational, okay? Rational numbers can be written as a fraction. Irrational numbers can't. What's an irrational number? Square root of 3. You cannot write the square root of 3 as a fraction. Ever. It's impossible. Okay? Square root of 4 you can, that's different, that's 2. But square root of 5 you can't. Square root of 6, square root of 7, square root of 8, no. Pi, that's irrational, you can't write that as a fraction. Some people say, wasn't pi 22 over 7? No, not really. 22 over 7 is like 3.14. But then after that, it messes up. Okay? So I'm going to show you guys a theorem for how to find where a graph would cross the x-axis if the answer is a fraction. Okay? If the answer is not a fraction, this isn't going to help. But if it's a fraction, I'm going to show you how to find it. And what this theorem basically involves, kind of the big picture here, is we make a list of options. Then we use the graphing calculator, which, hold on one second. Okay, so rational root theorem doesn't directly give you an answer. Okay, I want to make that clear. All the rational root theorem does is give you a list of possibilities. It's up to you to look at that list and use your calculator to help narrow the list down. All right. So suppose we had a polynomial. Okay, this looks kind of confusing, but a real problem would be something like that. 10x to the 5th minus 3x squared plus x minus 6. Okay, that's a polynomial. Okay, so you've got some kind of polynomial arranged in order, what we call descending order. Highest exponent term first, and then going down from there, finishing with a constant. Now, a couple important things here have to happen. All the coefficients, the things that I'm circling, all the numbers in front of the x's have to be rational. This theorem would not work if you tried to use it on a problem like this. Let's say you had square root of 2x squared minus 3x plus 1. Yes, that's a polynomial, but this theorem won't work. This number in front, this number right here, they have to be fractions. I mean, I could make that a fraction if I wanted. So the second one is a fraction. But square root of 2 isn't. Okay? So the coefficients have to be rational, and the leading term in the front and the constant cannot be 0. And they won't be in any problem that I give you. All right, so remember what Zach said. If something is rational, it means it can be written as a fraction. let's say that this number right here is a root. Don't worry about what P and Q are yet. Let's just say, you know what? We found an answer to a problem where it crosses the x-axis and it's a fraction. So here it is. It's the fraction P over Q. Well, I'm going to tell you what P and Q are. If you find a root, that's a fraction in your polynomial, the numerator has to be a factor of the constant. It has to be. So the numerator will be a factor of the last term. And the denominator has to be a factor of the number in front. Always. It's just a special trick that always works. So if a polynomial has a root that can be written as a fraction, I guarantee you the top number will be a factor of the constant. The bottom number will be a factor of the leading coefficient. So we can have lots of options. Like if you had a constant here that was 12, there's a lot of factors of 12. 1, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. That's a lot of different options, right? So what we're going to do now is use this theorem to make a list of options. And then I'll show you how we use the calculator to narrow the list down. So, again, just to emphasize, we're making a list of possible roots. I'm not saying that every single P over every single Q is a root. We still have to use the calculator to check, but at least we have a list of options so we know where we should be checking. So, let's try to list all possible rational zeros here. I'm just going to add in the word possible. Right, so the first thing we have to do is write down all the P's and Q's. What did I say earlier? P is a factor of the what?
Constant.
The constant. What's the constant here?
-6.
-6. So I want to know, what are all the numbers that divide into -6? Yeah.
-2, -3, 2, 3.
All right, so you said -2, +2. So plus or minus 2, you said plus or minus 3. Anything else? That's half of them.
6 and 1.
That's 3/4 of them.
Plus or minus 6.
Plus or minus 1, plus or minus 6. So there are 8 factors of the number 6. Or -6, same thing. Now we need Q. I said that Q is a factor of what? Yeah? Leading coefficient. Leading coefficient is 10. What are all the numbers that are factors of 10? Kid, tell me my factors of 10.
Plus or minus 2 and 5.
Okay, so plus or minus 2, plus or minus 5.
Plus or minus 1, 10.
Plus or minus 1, plus or minus 10. So we have a lot of possibilities here. We have to write every single one of them. We're going to do it in an organized way. We have to write every possible P we could have over every possible Q. All the combinations. So these are my possible rational roots. And I'll show you how you do it in an organized way. Let's start with the first P, 1. Let's do that one over every single Q. So we could have 1 over 1. We could have 1 over 2. We could have 1 over 5. And we could have 1 over 10. Those are all the different rational roots you could have with a 1 in the top. Now let's do all the roots we could have with a 2 in the top. Can somebody start start giving me those. Yep.
Plus or minus 2,
Okay.
plus or minus 1.
And plus or minus 2 over 2, which reduces to 1, and we already have that one. Yep.
Plus or minus 2 over 5.
Yep, we don't have that one.
Then plus or minus 1 over 5 because it reduces.
Yep, plus or minus 2/10, which is 1 over 5, and we already have that one. So we don't have to write it twice if we already have it. All right. How about somebody else, my roots with a 3 in the top? Yes?
3/5.
Eventually, yep, what would be the first one?
It'll be 3.
Yep, plus or minus 3, good.
Next will be 2. Wait. 3. 3.5. 3. Alright.
You want to help him out? What would be the next one? Yep. Plus or minus 3 over
2.
2. Then plus or minus
3 over 5.
3 over 5. And plus or minus 3 over 10. Now let's do our roots with a 6 in the top. Eric, what would be the first one?
Plus or minus 6 over 1.
Yep, so 6 over 1. Next one, plus or minus 6 over 2. But what's 6 over 2? I already have 3, so I don't have to worry about that. 6 over 5. Didn't have that one. And the last one, 6 over 10. But what does 6 over 10 reduce to?
3/5.
I already have that one. So we get a total of 4, 8, 10, 12, 24 possible rational roots. So what this list says is if you graph this polynomial and it is going to cross the x-axis, if it crosses at a spot that's a fraction, it has to be one of those numbers. It has to be. It can't cross the x-axis in a spot that's a fraction and not be a number in that list. It has to cross at a number in that list if it's going to cross at a fraction. This graph might not even cross at a fractional number. But if it does, I guarantee you it's one of those. Okay, so any questions on that? All right, so now I want to take that graph, I want to plug it into the calculator, and I want to prove that it crosses the x-axis only one time, and that where it crosses is irrational. I want to prove that this graph never crosses the x-axis at a number that's a fraction. Right? So we're going to use the graphing calculator to help us. So let's type it in. Okay, and we've got 10x to the 5th minus 3x squared minus 3x squared plus x minus 6. And I'm gonna do zoom 6 so we can zoom out a little bit. Okay, so I can see where it looks pretty close to something. Let's put that graph on this page. Now, one thing that you've got to be able to do is get the graph on the page, eventually, there we go, is you've got to be able to look at your graph and narrow this list down. Okay. It looks like it crosses the x-axis pretty close to what number? 1. So let's look at our list and let's just narrow the list down a little bit. Does it look like it crosses near -1? No. Does it look like it crosses near positive or negative a half? No, doesn't look like that. Positive or negative a fifth? No. Positive or negative a tenth? No. So most of the possibilities that you generate, they don't make a lot of sense. They're still possibilities. It's just they don't work in this graph. How about plus or minus 2? You think, Sam?
Yeah.
It looks like this graph is near right here?
No.
Or near right here? No. How about plus or minus 2/5? 2/5 is 0.4. You look close to 0.4? No. Plus or minus 3?
No.
That's even worse than plus or minus 2. That's no. How about plus or minus 1.5?
No.
Not really. Plus or minus 3/5? That's 0.6. Plus or minus 3/10? No. Plus or minus 6? It's nowhere near that. Now, how about negative 6/5? No. Positive 6/5, I'd say maybe. I mean, 6/5 is like 1 1/5. Maybe if you zoom in there, I mean, it could be like 1.2. So if you said to me, like if I said to you, okay, eliminate the possibilities, now make me a new list of the ones that seem reasonable here, you could make an argument that plus 1 is reasonable, and I would say plus 6/5. Those would be the only two that I think are even remotely reasonable. Okay? Now, let's actually calculate what the 0 is. So the actual 0 is, pick a point to the left, pick a point to the right, do your guess. 0.9505. Is 0.9505 a number that was in this list? So what does that mean about the number 0.9505? It must be what? It must be irrational. Because if it was rational, it would have been in this list. And it's not. Right? So this is how we answer the question. So, using a graphing calculator, the root is about, again, I'm rounding it, it's not really 0.9505, right? It goes on forever. It's about 0.9505. And 0.9505 is not a number in my list of possible rational roots. Possible rational roots. So, it has to be irrational. Okay. Any questions on that? So 0.9505 was a number that is the root. There is no fraction in this list that's even close to 0.9505. And these are all rational possibilities. And it's not here. So the only other option is that answer we found must be irrational. Okay, but you're going to use a graphing calculator to help you with the rational root theorem pretty much every time you do it. Any questions on that? Okay, so we're going to come back. We are going to do another one with the rational root theorem because it takes a little practice with the P's and Q's. But I want to be able to do that in conjunction with synthetic division. Right? So now I'm going to show you a quick way to do division. Downside is it's only going to work some of the time. Now, in your book, they don't call it synthetic division. They call it Horner's algorithm. So they name it, I think they name it after the person that discovered it. But everybody I've ever heard that talks about it, they use the term synthetic division. They don't say Horner's algorithm. Okay. So when you see that in the homework, you'll know what they want you to do. So I'm going to give you all the steps for synthetic division first, and then we'll go through a problem. Okay, so I'll give people So you know what, we can do it like we did yesterday, I guess. I can give you one step, then we can do the step, so you kind of see how it works. So first of all, if you read what I wrote up above, this only works if you're dividing by x minus c. If you're dividing by like x squared or x cubed, you got to go back to long division. That's what we learned yesterday. But if you're dividing by x minus a number, you can do this. So step one is to take the number that's in that box, take the number after the minus sign, and put it on the outside of a bracket. Then next to that, you're going to fill in all your coefficients from the numerator. Just like long division, fill in zeros if you're missing any powers. So we're gonna do this first. So leave yourself, I think there's 4 steps. So I'd leave yourself maybe 4 or 5 more lines. And then we're gonna start an example. But if you want to put all your steps together, just leave yourself like 5 lines. Okay, let's look at our example. So, in order to do our example, you kind of got to remember what I showed you yesterday. If I had something, again, just watch this. If I had something like this, and I wanted to show 2 is a root. What else does that mean? If 2 is a root, then what is a factor? Yeah.
Negative 2. For x minus 2.
X minus 2. So what I'm really going to be showing is if I want to do this, I'm going to show this is a factor. That's what I'm really going to do. Okay? So you want to know this, I'll show you this, which means the same thing. Now, how do you show something as a factor? What do you do? Like if I said to you, prove to me 5 is a factor of 15, how would you prove it? What's that? Division. And what do? You do the division and then what? So the division is the tool, but then you got to look at what the division tells you. If something is a factor, what's going to happen when you do the division? How? Numerically, what's going to happen? Yeah?
It'll show you what times 5 gets you 15.
Okay, think about long division. What are your 2 parts to your answer when you do long division? Quotient and remainder. Yes. What's going to happen with the remainder? It's going to be 0. Okay. That's what you're really trying to show here. So if you want me to show this is a root, I'm going to show that this is a factor. And how am I going to do that? Long division will give me, long division gives a remainder of 0. Okay. So you're going to do the division and get a remainder of 0. Now today we're going to have a better way to do the remainder. We're not going to have to do long division. We're going to do synthetic. But it's going to be the same thing. We're going to show that the remainder is 0. Okay, that's the goal. So let's look at our problem, and then we'll look at the steps. So the directions here are to show that 3/2 is a 0. So what am I really going to show? I'm not going to show directly that 3/2 is a 0. I'm going to show that what is a factor? I'm going to show this is a factor. And how am I going to show that's a factor? I'm going to divide this into this and hope that I get a remainder of what? There you go. I'm going to hope I get a remainder of 0. Okay? So that's the process. So First thing it says to do is make sure you're dividing by x minus a number. Are we doing x minus a number here? Yeah. So take the number after the minus sign, put it on the outside of a little bracket. Now, put all the numbers for the coefficients next to it. Am I missing any terms from cubed to constant? Am I missing anything?
No.
No. So 2, -5, 1, 3. Put those numbers down. And that's step 1. If you want, you can make a line here too, because you're going to need a line. The nice thing about this is this problem is not going to take up any more space than 3 lines on a piece of paper. If you count this as 1, the blank is 2, and then below the line is 3. It's not like long division. You're going to need more and more space. No. That's all the space you're going to need to do this problem. It's all going to fit inside this box right there. Okay, so next step. Very simple. Bring down the first coefficient. So, Jacob, if I go back here, what is my first coefficient?
Two.
2. Bring it down. So my first coefficient, 2. Next step. Multiply the number. I'll just read it and then I'll explain it even more simply. Multiply the divisor by the number you just brought down and write that answer in the second column. Multiply the number on the outside by the number you just brought down and write the answer in the second column. Okay, so let's do that. Multiply the number on the outside by the number I just brought down and put the answer in the second column. What's 3/2 times 2? 3. Put the answer right there. Now, still part of the same step. Add those numbers up. Add the number that Chris just told me, 3, and the one that's above it. So we're going to add up the column we just created. A little different than long division. Long division you subtract. Synthetic division, you add. Okay. So now add this column. What's -5 plus 3? -2. And now you keep repeating this process until you know this number right there. That's when you're done. Okay, so we have two more rounds of synthetic division to do. So repeat this until we're done. Now, once you're done, you have to be able to interpret the work that you've done and know what your answer is. I'll tell you how to do that after. So for now, I'm just going to say repeat until done, and then I'll show you the rest when we're done. Okay. So now multiply what's 3/2 times -2.
-3.
-3. Put the answer there and add. What's 1 plus -3?
2. 1 plus
-2.
-2.
One more time. -2 times 3/2.
No, 3. 3.
-3. And what's 3 plus -3?
0.
0. Based on what the problem was telling you to do, what do you think that 0 is? Yep. Yep. That's my remainder. Now, when you do division, you get a remainder and you get a what? You get a quotient. That's your quotient. So, I can write that down a little more formally, but basically that last row contains the coefficients of the quotient, and the very last number, all the way to the right, is your remainder. Okay, so that last row contains the coefficients of the quotient, and the very last number in that row is your remainder. Okay, so I'm going to show you how you could write your answer. They didn't ask you to do this part right here, but I'm just going to show you. So if they wanted to know the quotient is, you start on the right, constant, linear, squared term. 2x squared minus 2 with an x, and then my constant is minus 2. That's my quotient. That's my remainder. So we've done what they wanted. We showed that 3/2 is a root by showing x minus 3/2 divided into my problem without a remainder. If something goes in without a remainder, that means it's a factor. So what that tells you is, look at the original problem. What was it? 2x cubed minus 5x squared plus x plus 3. What did we just prove as a factor?
3 over 2.
3 over 2 is a root.
Or x minus 3 over 2.
X minus 3 over 2 is a factor. So if you were going to factor this, there's one of the factors. The other factor would be your what? Yeah, it's your quotient. Just like if I said to you 12 equals 3 times something. Well, if you want to figure out what goes here, divide the factor that you know into the number and get the quotient. 3 goes into 12 4 times. X minus 3/2 goes into this that many times. 2x squared minus 2x minus 2. So now I've just factored a cubic. Okay. They helped me because they told me what number to try. But now with the rational root theorem, you should know how they got this number. The factors of p and the factors of q. 3 over 2 is one of the p over q's. So the next step to this problem would be, okay, now you have to figure out this number yourself and then do the problem from there. Okay? But this time they gave you the number to try. Okay, so any questions on how we proved 3/2 was a 0? All right. So let's just try another synthetic division problem, and then we're going to kind of tie this together with rational root theorem. Now, with synthetic division, you always have to divide by what operation has to be in the denominator. X has to be minus. Are we dividing by x minus a number here? Not really. Couldn't we make it x minus a number?
Yeah.
How could we make it x minus a number? Use a negative number. You have to do that. So now when I do synthetic division, what's going to be the number that goes inside my bracket right there?
-3.
-3. It's always the number that would be in this box right there. It's the number after the x minus. Okay. And can someone else tell me my coefficients that I'm going to put in? Chris?
3, 7, 1.
Careful. 3, 7,
1.
0.
Oh.
Why? Caleb? There's no x squared. Okay, we can't forget that. There's no x squared, then the 1, then the -11. Now, I'm going to just go through this problem kind of at normal, well, it won't quite be normal speed because I'm going to talk out loud as I do it, but watch how fast we can do this whole problem. Bring down the 3. 3 times -3 is -9. 7 combined with -9, -2. times negative 3, 6. Added to 0, 6. Negative 3 times 6, negative 18. Negative 18 plus 1, negative 17. Negative 17 times negative 3 is 51. And 51 minus 11 is 40. Look how quick that was, right? Way faster than doing long division. Long division would probably still be on the first step. Is there any questions what I did there? Okay, so what's my remainder? 40. And my quotient is constant, linear, squared, cubed. 3x cubed minus 2x squared plus 6x minus 17. So, I want you to focus on this. I got a remainder of 40. What does that mean about x plus 3? Yeah?
It's not a factor.
It is not a factor. If you were trying to factor this, x plus 3 is not what you should be using. It doesn't go in without a remainder. So if x plus 3 is not a factor, what else does that mean? What is not a root?
Negative 3.
Negative 3 is not a root. Negative 3 is not a spot where this graph would cross the x-intercept. It's not a spot where it would cross the x-axis. Okay, so let's show that 3 is not a root. Now there's two ways to do it. You could just plug 3 in for x and see what you get. Right? If you plug in 3 for x and you get something that's not 0, then you've shown it's not a 0. But let's do it kind of the way we've been doing it today. Instead of showing 3 is not a root, I'm going to show that what is not a factor.
X plus 3 minus 3.
X minus, what do I want to show is not a root?
3.
3. I'm going to show that x minus 3 is not a factor. And how am I going to show something is not a factor? I'm going to do the division and hope what? Yep. Hope that I get a remainder that's anything except 0. Anything. So let's do it. 3 on the outside. 2, 5, negative 2, negative 3. Come down to 2. 3 times 2? 6. 5 plus 6? 3 times 11?
33.
Negative 2 plus 33? 31 times 3?
93.
And 93 plus negative 3?
90.
90. Since I got a remainder of 90, that means x minus 3 didn't divide into that evenly. That means 3 is not a root. That's it. Any questions on that one? All right. So now, how do we kind of do a problem from scratch? Okay, I've kind of guided you through where I said, okay, show that this is or isn't a root. Now you're going to have to figure that number out on your own. So the way you're going to do it is you're going to start with the rational root theorem. You're going to make a list of possibilities. Step 2, use the graphing calculator to narrow down that list of possibilities. And then, once you find one that works, and there will always be one, otherwise you're not going to be able to solve it. Once you find one that works, divide through by it synthetically. Now remember, each time you do synthetic division, look at what happens. In this original problem, what was my highest exponent? 4. Once I did the synthetic division, what was my highest exponent? 3. Every time you do synthetic division, the exponent drops 1. And the real goal is to get that down to a 2. Because if you can get it down to a 2, then we know how to solve it. That's a quadratic. We can use quadratic formula. But until you get that exponent down to a 2, we can't really do much with it. So that's the goal. you're not really going to have to divide probably more than once or twice, right? Like in this one, I'm starting you off with a cubic. So all you need to do is find a number that works and use synthetic division one time, and then you'll make this into a quadratic. Okay? You just have to find one that works. So let's start with the rational root theorem. Okay. P, factors of the constant. Can somebody tell me what are my factors of the constant here?
-2, plus or minus 2, plus or minus 4.
You don't have as many options like we did in the first one. It's going to be a very small list. Plus or minus 1, plus or minus 2. And what are the factors of Q? Remember, Q is the factors of your leading term, the coefficient in front. What coefficient's in front here? It's not written, yeah?
1.
1. What are the factors of 1?
1,
Yep.
plus or minus 1.
Plus or minus 1. So remember, it's P over Q. Does putting something over 1 make a difference? No. So really, Q doesn't even matter this time. So my possible rational roots are plus or minus 1 over 1, plus or minus 2 over 1. That's it. If this graph is going to cross the x-axis at a nice number, it's either plus 1, minus 1, plus 2, or minus 2. It's got to be one of those four. Because if it's not, you're not going to be able to finish this problem. Okay? So it will be. So let's graph it and see. X cubed minus 3x minus 2. Out of plus 1, minus 1, plus 2, and minus 2, which ones look reasonable? Yeah?
-1 and plus 2.
Yeah, they both look reasonable. If there are two that look reasonable, it doesn't matter which one you do synthetic division with first. Let's try the 2. I'm going to trace to 2, and I showed that it is a root. The reason I wanted to check that it was 0 is because I don't want to waste time doing synthetic division, and I used the wrong one. Maybe this would have actually been like 1.99 or something. Maybe it wasn't 2. Okay, but it is. Okay, 2 is the root. Okay, so we're going to make a list of roots. 2 is one of them. Now, you're going to use synthetic division and divide through by the root. When you do that, this exponent is going to turn from a 3 into a what? 2. It's going to turn into a 2, and then it's going to be a quadratic that we can probably factor. Okay, so let's divide through by synthetic division. We already know the remainder. The remainder should be 0. If it's not, we did something wrong. So we've got 1, don't forget your 0, -3, -2. Okay, bring down the 1. 2 times 1? 2. 0 plus 2? 2. 2 times 2?
4.
-3 plus 4?
1.
2 times 1? 2. -2 plus 2?
0.
There's your remainder. Now I'm interested in the quotient. X squared plus 2x plus 1. Now, find the zeros there. Find the roots of your quotient. And we'll add those to our list. Okay, so we got the first one. How does x squared plus 2x plus 1 factor?
X plus 1, X plus 1.
Yep, x plus 1, x plus 1. If it didn't factor or you got stuck, you could use quadratic formula, but boy, it's like using a chainsaw to cut a piece of paper on this problem. You don't need that. If you can factor it, it's a lot faster. Now, what would you plug in for x to make the first factor 0? How about to make the second one 0?
-1.
-1. So -1 is what we call a repeated root. A repeated root, you can tell by looking at the picture, it usually comes up, it touches the axis, and it bounces away. Because if it went through and crossed it, you would have got two different answers. Okay? So the roots in this problem are 2 and -1. You don't need to write -1 twice. And that's it. Any questions on that? Yeah?
So if it touches the line, it's not like crossing it?
Right, it's not crossing it, it's just touching the axis and bouncing away. It's never actually crossing through it. Yep. So we got this one, which is kind of the same. The last two are kind of the same. Let's do this one. Find all real zeros. Now, what's the degree on that equation? Zach? 3. I don't like degree 3. I don't like degree 3 because I don't know how to solve degree 3. It's a cubic. I know how to solve degree 2. That's a quadratic. So I got to turn that into a quadratic. The only way to turn it into a quadratic is to find the p's and q's and get one that works. And then use synthetic division. Or long division, if you don't like synthetic, but I think synthetic is faster. So, what are all my possible p's in this problem? Chris?
Plus and minus 1.
Yep.
Plus and minus 2.
And what are all my possible q's?
Plus and minus 3. And plus and minus 1.
Yep. So not that bad. We got a few possibilities we got to write out. So possible, rational, roots. So right now, I'm focusing on the rational roots. But remember what the question said. Find all real. Real means rational and the irrational. So even if this problem doesn't factor when we're done, they still want to know the answers somehow. Okay? So then we're going to have to use quadratic formula. If it doesn't factor. Okay, let's see what happens. So, what are my possible rational roots? 1 plus or minus 1.
Plus minus 2.
Plus or minus 2.
Plus or minus 1/3. Plus.
I have an extra space.
Plus and minus. Plus and minus 1 second. Plus and minus
No, it's not a half. Yep. 2/3. 1 over 1, 1 over 3, 2 over 1, 2 over 3.
Oh, I thought because there was space between 1 and.
No, I just have trouble leaving spaces and talking and teaching and writing and breathing at the same time. So now we have to graph it and see which one of those looks reasonable. So let's see. 3x cubed minus 8x squared plus x plus 2. Okay, so out of our possibilities, can somebody tell me which one looks reasonable? Jack? 1? Let's try it. And maybe if I make it even bigger, you can see it. Does it look like it crosses at 1? Not quite. So, which one? Yeah, I would say positive 2/3 looks pretty good. Before we waste time on synthetic division, let's check it here. So let's trace to 2/3. Perfect. We've got a root. We can divide through by it. We can turn this cubic into a quadratic. Okay, so positive 2/3 was the answer. 2/3. Just that. 3, negative 8, 1, 2. Not missing anything. Okay, we already know that the remainder should be what? Should be 0. I'm hoping to get a negative 2 at this last step. Let's see what happens. Bring down the 3. What's 2/3 times 3? 2. Negative 8 plus 2? Negative 6. And now 2/3 of negative 6. That's negative 4. Plus 1. What's negative 3 times 2/3? Perfect. Negative 2 plus 2, 0. Now, find the roots there. So let's start a list. Roots. 2/3. And it says to classify it as rational or irrational, that's a fraction. That's rational. Now, 3x squared minus 6x minus 3. You can try really hard, but you're not going to be able to factor that. I can just tell by looking. It's not factorable. So, if you can't factor it, what's the other way you can solve a quadratic? Yep. A is 3, B is negative 6, C is negative 3. Whatever we get for answers, I'm going to put them right over here. Right in that circle. Okay, so quadratic formula, what comes first? Careful. Well, yeah, it's going to be x equals, not b, negative b, in which case is negative 6, plus or minus b squared, good, good, over 2a. Let's clean that up, and that's our answer. 6 plus or minus, you're going to be subtracting a negative, so what does that mean? Yeah, you're going to be subtracting a negative, so that's going to turn to addition. What's 4 times 3? And then 12 times 3 is 36. 36 plus 36 is 72. Now, 72 you can simplify. Anybody think how you can break up 72? Into two numbers, something times something. And one of those numbers is a perfect square. Yeah, 36 and 2. What's the square root of 36? So now you get 6 plus or minus 6 roots of 2 over 6. And now look what happens. What can you cancel out of everything? A 6. 6 goes into 6 once. 6 goes into 6 once. 6 goes into 6 once. So final answer, 1 plus or minus square root of 2. Those are the other two roots. And because you have a square root in there, is that rational or irrational? Irrational. 1 plus or minus square root of 2. When you're doing this, it is impossible to find the irrational roots first. You can't. You have to get the rational one and do synthetic division. Even the calculator won't tell you this. Calculator will tell you a decimal, but on the test, if I say no decimals, you're going to have to use quadratic formula, okay? Which means you had to do synthetic division before that. Okay, so that's how you use the rational root theorem together with synthetic division. And this one wasn't factorable, so this is worst case scenario. Hardest type right here. So homework for tonight, it's on 183, and it's 1, 2, 5, 6, 9, 10, 13, 14, and 17, 18, 27. Okay, so we'll go over that first thing tomorrow, and then tomorrow we will finish up with section 3.5, which now takes this one step further and says, well, what if we get imaginary answers? That's okay too. So we'll look at what happens when we have imaginaries.